can see from the title of this video, this tutorial is about double replacement reactions. Double replacement reactions are the fourth type of chemical reaction that we'll learn about. Just like we've done for the previous three, the first thing we're going to do is list how we can tell if something is a double replacement reaction, and then tell you how is it that we get ourselves to the correct answer. Double replacement reactions are pretty straightforward. The way you can tell something is a double replacement is it is a compound plus a compound. In single replacement reactions, we always found like charges and traded, and then we checked our activity series to make sure that could occur. In double replacement reactions, we do something similar. We find like charges in trade, the only difference is we don't have to check an activity series. All double replacement reactions will occur. We don't need to see if something is more powerful than something else. So in some ways they're much easier because we know they automatically occur. Let's take a look at a few examples of some double replacement reactions. First example, strontium oxide plus Mercury III nitride. So as you take a look, the first thing that's always the most important is identify the type of reaction. Right? So is it a synthesis? No, it's not an element plus an element. Is it a decomp? No, there's more than one reactant. Is it a single replacement? It's a compound plus a compound. That would have had to be an element. Is it a double? Yes, compound plus a compound. According to this, we find like charges in trade. So you go to the periodic table and you see where things are. Strontium's to the left of the staircase, which makes it positive. Oxide's to the right, group 16, negative. Mercury's to the left, positive. Nitride to the right, negative. So just like with single replacements, we will trade like charges. It does not matter if you flip your negatives or your positives. So I will just arbitrarily decide to trade the positives. If we do that, pull Mercury up, pull strontium up, put strontium in, put Mercury in, you end up with Mercury III oxide plus strontium nitride. Notice the Roman numeral carries with Mercury over to the other side. And if you would have reversed these, if you said strontium nitride plus Mercury 3 oxide, that's also fine. So long as you just have the right things paired, you are good. Now it's just a matter of writing and balancing it. Right? Strontium oxide, Mercury nitride, Mercury oxide, and strontium nitride are all compounds. None of them have prefixes. So we will do symbols and charges to get all of them. Strontium is Sr plus 2, oxygen O negative 2, cross and reduce, and you get SrO. Mercury is Hg. The Roman numeral 3 tells me it's plus 3. Nitride is N. Group 15 gets a minus 3. Cross and reduce, HgN. Over to the other side, Mercury 3 oxide, Hg plus 3, O negative 2. Cross and reduce, looks like Hg2O3. And lastly, strontium nitride, Sr plus 2, N negative 3, cross and reduce, Sr3N2. Now it's a matter of balancing it. So if we take a look, save O's and H's for last, so we have to save this O till the end. So we start with, say, strontium. I see 1 strontium on the left, 3 strontiums on the right. So to fix that, I'll put a 3 in front of SR. Now we'll move on to either nitrogen or mercury. Let's say mercury. 1 Hg here, 2 Hgs here, means I'll have to put a 2 in front of HGN. Now we take a look at nitrogen. 2 times N here is 2 Ns. 1 times 2N, 2 Ns, so we're good. And then lastly, oxygen. 3 times an O here is 3. 1 times 3 O's is 3. That equation is balanced. So the idea is find like charges and trade them. No worries about the activity series. And then you simply have to write and balance the equation. Let's take a look at one more. How about magnesium acetate plus ammonium bromide. Okay, magnesium acetate plus ammonium bromide. Again, first important thing is identifying type of reaction. Is this a single replacement? No. Synthesis? No. Decomp? No. You'll see it's a compound plus a compound. That makes it a double replacement. Now we identify charge. Magnesium is to the left of the staircase, so it's a plus. Acetate's a polyion, so how do we know their charges? Well, we had to memorize it. Acetate's charge is a -1. Ammonium is also a polyion. It's a +1, so here's a plus. And bromide is group 17. It's a minus. So here I traded positives arbitrarily. I just want to show you that we could just as easily trade our negatives. So acetate and bromide are going to flip. If I do that, I get magnesium bromide plus ammonium acetate. And now we want to write and balance this thing. So, magnesium acetate, ammonium bromide, magnesium bromide, and ammonium acetate are all compounds. None of them have prefixes, which means we are going to do symbols and charges and cross them for every one of these. So magnesium is Mg plus 2. Acetate's a polyion, C2H3O2 minus 1. Cross those down. You get Mg parentheses C2H3O2 parentheses 2. Ammonium bromide. Ammonium's the polyion this time, so NH4 plus 1, Br minus 1. Cross them down. NH4Br. Over to the other side, magnesium bromide. Mg plus 2, Br minus 1. Cross those down. MgBr2. And lastly, ammonium acetate, NH4 plus 1, C2H3O2 minus 1. Cross and reduce. NH4C2H3O2. Last but not least, we need to balance it. Start with our polyions, then move on to elements that are not H and O, finishing with H and O. So I see one polyion here, acetate, all right, and I see it has a partner over there, so we can keep it together. So there's 2 acetates here, only 1 over here, so I'll put a 2 here to get the acetates to be the same. That gives me 2 NH4s here. I only have 1 here, so to fix that, I'll put a 2 here. That makes me have 2 bromines. I have 2 bromines, so we're good there. And lastly, 1 magnesium, 1 magnesium. This equation is now balanced. So double replacement, pretty mechanical, find like charges, trade, and then from there out, the whole idea is symbols and charges, cross them, and make sure you can get your equation balanced. I hope this helped you sort out any troubles you may have been having. As always, if not, please feel free to come in for some help.